In this video, I want to do a warm-up problem where we review some of the stuff that we talked about in the last section on limits, but I do a limit sketching example. So the problem is I want to sketch the graph of a function f that satisfies the following properties. So there are 5 properties. Okay, so there are a few limit properties, and then it also tells me 2 pieces of info where it says like f of a number equals some number. So I need to sketch the graph of a function that satisfies these properties. So, okay, let me zoom out a little bit so I can still see the properties when I go about sketching this. Okay, so I'm going to draw some axes. Let's put some tick marks on them. So I'll go 1, 2, 3, 4, 5. And the positive x direction, -1, 2, 3, 4, 5. So that's -5. Let's go in the y direction as well. I'll go 1, 2, 3, 4, 5. Negative y direction, -1, 2, 3, 4, 5. So -5. Okay, and I actually want to give you all the chance to try this first. So pause the video for about 2 to 3 minutes. 2 to 3 minutes to try this problem. So 4, 3, 2, 1, pause the video. Pause the video and try this for about 2 to 3 minutes and think about how such a graph might look like. There's way more than one possible answer here. The problem just said just to sketch a graph, a possible function that satisfies these. So also, you don't need to give me a specific formula here. You just need to sketch the graph. All right, so hopefully you've paused the video for about 2 to 3 minutes to really try this. So let's get into it. So I'm going to start off by graphing the things that look easiest. So f of -2 equals -3, that looks not too bad. So when x is -2, my y value needs to be -3, so that's that point right there. And then f of 3 needs to be equal to 0. So let's draw those 2 points. Okay, at this point we've checked off this condition and this condition. They're both satisfied. All right, what about the first condition now? All of these others are limits, so we have to kind of start somewhere with the limits. Let's start with the first limit. The limit as x approaches -2 from the left is -∞. So the key thing that I want to point out about this is, so if we start to draw this graph, so as x gets really close to -2, which is here, here's the tick mark for -2, the y values are approaching -∞, which means our graph is doing something like this. X getting really, really close to -2, but the y values are going to -∞. That seems to be asymptoting. Seems to be asymptoting down this way. And indeed, that's the case. So let me state a property that's true in general, which is if I do a limit, a one-sided limit, either as you approach the left-hand side of A, and that limit is either positive or -∞, or if you do the limit as x approaches A from the right, and we indicate that by putting a plus sign in the exponent, if the limit as you approach A from the right is positive or -∞, the graph has a vertical asymptote. At x equals A. And that's what we observed was happening here. So we were able to sort of determine this by just thinking about, well, what do we mean about the graph? As x gets close to -2, the graph seems to descend to an infinitely negative number here. Okay, I don't really know what the graph is going to look like to the over here. Like, I don't know if it's going to go up, or let me erase that, or if it's going to go down like that. So let me not draw that part of the graph just yet. I'll wait till I've described everything, and then I'll fill in the stuff that I have some freedom to decide. So, okay, we've done this one. We've done that first limit. Well, let's do the next limit now. So the next limit is the limit as x approaches -2 from the right-hand side needs to be 1. Okay, so as x gets close to -2 from the right-hand side, the y values need to be getting close to 1. So I'm just going to start to draw a graph where the y values seem to be getting close to 1, getting really, really close to 1. Here's where 1 is. Can I put a closed circle here? Pause the video for 30 seconds and think about that. Can I put a closed circle at that point where I just put it? 4, 3, 2, 1. Pause the video. Pause the video for about 30 seconds to think about that. All right, so hopefully you've done that. Hopefully you've paused the video. The answer is no. I can't put a closed circle there because we already had a closed circle at -2, -3 down here. So because I can't put a closed circle at that point, the only option is I have to have a hole there. There's got to be something there because the y values need to be getting close to 1. That's what this limit, the second limit says. But it's got to be a hole. Okay, so the coordinates of this hole are -2, 1. Okay, and now we've satisfied that second condition. Okay, and notice I've deliberately just drawn a small part of the curve because I don't know how this might connect with other parts. Okay, so there's one other limit left to do, which is this limit as x approaches 3 of f of x being equal to 4. And this is a two-sided limit. So on both sides of 3, as x gets close to 3, the y values need to approach 4. So let's start to draw that. So 4 is here, that's the y value 4. So as x, and here's x equals 3. So as you get close to 3 from the left-hand side, the y values need to get close to 4. And same thing from the right-hand side, the y values need to get close to 4. Can I put a closed circle there? And the answer is no, because I already have a closed circle down here where x equals 3. So this one's got to be open as well. Okay, and now this picture has satisfied this remaining limit. I've actually satisfied all of these, which means for everything else where I just have blank space, I could decide whatever I want it to look like. So if I want to make my graph look like up and go down and then go up again, sure, I can. Or if I just want to make this part go completely flat and horizontal, I can. So maybe this other part to the left here, maybe let me just have that go upwards. I have flexibility for all those parts that I just connected. So that is it for this warm-up problem. We have sketched this graph. We have sketched a possible graph that satisfies these properties. In the next video, we're going to give the definition of continuity, what it means for a function to be continuous at a point.